Hi everyone, so today we are here with a new problem and this is a Leetcode hard problem and let's see what is the problem. So in this problem we have a given string and in this string we have characters which is a open bracket and a closing bracket and we have to find the length of the longest valid parenthesis substring. So first you need to understand what is a valid. So if there is a opening and closing bracket then it is a valid parenthesis, right? And we want the length of longest valid parenthesis substring. Okay, so as you know, substring means a continuous part, right? And we want the length, right? So if you see this example, in that case there is a 2 length and in this case there is a 4 length. That's why 4 is the answer. Now there are two things. The first thing is we have to understand how we can check whether the parenthesis is valid or not. If you done these type of our problems before, okay, you can see in order to find whether the parenthesis is valid or not, we have to use stack. How we basically use stack? We basically take a stack and let's suppose if this string is like this, we iterate the whole string and push. If we get the open bracket we put it, and if we get the open bracket we put it, and whenever we get the closing bracket, and at that point we will check if the top of the stack is a opening bracket, it means there is a one valid parenthesis, so we will push out, and this is a one valid parenthesis. Similarly we go and we will check that it is a opening bracket, we will push it, and when it is a closing bracket we will check whether the top of stack is open. Yes, it is open, we will remove out, so this is one more valid parenthesis. So this is the way how we are actually find out whether the parentheses are valid or not. But here the problem is we want the length, we want the length of valid parenthesis substring. So as you know, in that case when we get one valid parenthesis, we simply check if the top of the stack is open, there is one valid. But when we reach here, let's suppose for the second valid parenthesis, how we come to know that before we have one existed valid parenthesis and it is continuous, right? So for this, first understand one thing. Let's suppose we have a string which is open, this, and like this, right? Now you can see that this is one valid parenthesis substring, and you can also okay. Let me change the example so that you can understand more. Okay. Uh-huh. Right. Now you can see that this is a valid parenthesis, this is a valid parenthesis, and this is a valid parenthesis, right? And there is this have like length 2, it is a length 2 substring, and it is also length 2 substring, right? Now how we can differentiate that this is one substring, this is one substring, this is one substring, because of a discontinuous nature of the string, because of discontinuous nature. So uh, discontinuous nature means parenthesis which actually uh, don't point to the validity of the parenthesis, right? Like you can see that if we add open parenthesis in this tag and a closing parenthesis, so both are cut out, right? And in that case the stack is empty, and when we get a new parenthesis which is closing one, but in this tag we don't have any opening one, in that case we can say this is a discontinuous part, right? On the other hand, if we take example like this, right, in that case you can see that this is one substring and this is whole of one substring, right? And how we come to know? Because the discontinuous nature we find at this position, right? And after that we don't find any discontinuous nature. And that's how, if we come to know at which index we see this discontinuous nature, we can simply find out the substring length for valid parenthesis. But how we can do it? Let's understand this. And there is one more trick which I will tell you. Before that, let's see this example. So the example is, right. So what we do, we take two stacks. So in first stack, we basically push the brackets, and in the another stack, we push the index. So let me write the index. So we are at this position, and right now our stack is empty. So we push this and also push the index. Now we see another uh, parenthesis which is a closing. When we get a closing parenthesis, we will check if our stack is not empty, and if the top of stack contains an opening bracket, it means we get one valid parenthesis, right? So right now you can see that, okay, we will remove this, and at the first index we see the closing parenthesis, right? But in order to work in this algorithm, we have to push -1 already there. Why? I will tell you after some time. For now, you can simply have to push -1, and I will explain this part. Just wait. So when I get this, what I do in this case, I simply pop this, okay, and before that I have 0, right? And I also pop 0 in it, and at the position where I get the closing parenthesis, what we will do 1 minus the top of the peak, which is 1 minus -1, which is 2. So right now my answer is 2, which is the 2 length, right? Let's go on and you will understand it more. So we will see there is one more closing parenthesis. So this closing parenthesis tells that this is a discontinuous, right? This is a discontinuous nature for validity of parenthesis. So we will push this index, right? Why we push this? Because it tells at index number 2 we have an invalidity. But before that, if at any position we don't get any invalidity, it means we are getting a valid substance. You can understand little bit, wait for it. So at this we are getting the open parenthesis, and we also push 3 as an index. Now, when we get a closing parenthesis and we will check the top of stack, we will remove this, and at position 4, we get this, and whatever the top of the stack, which is 2. So it is 2, so we basically maintain the maximum value. So we are getting 2, so already there is 2, so we don't update it. Now let's move on. Let me remove this, and let me remove this. Now let's go on. So there is opening and there is 5. Now there is a 6, which is a closing parenthesis. We will check the top of stack, and stack is not empty, so yes, it is an opening bracket. We will remove this, and we will remove this. Now at this position you come to know why I add this array, sorry, why I add this index. because it tells this is the position where we get the discontinuous nature last time. Okay, and in order to maintain this, we are push -1 in the starting for that case, right? If we don't get invalidity in starting, we have to push -1. I think you get it. So at index number 6, you get the closing parenthesis -2, which is 4, and 4 is maximum than 2, so we are updating this. Let's move on. This is a closing parenthesis, so we will put 7. At the end, this is the answer we have, and we can simply return it. So let's see the code, how we can code it. It is easy as I describe you. So we are taking two arrays and we are push -1 for our algorithm, and this is the answer we store. If we get the open parenthesis, we don't do anything, we simply push the character and the index of that character. And if it is a closing parenthesis, right, else means it is a closing parenthesis, then we check if our stack is not empty and our top of stack containing a open parenthesis, it means we get valid parenthesis. So what we do, we'll pop out the character, we will pop out the index, and we will find the length. How? The index we are at, this index specifies the closing parentheses, right, we are at, and this specifies the last discontinuous point for validity. Then we get the length and we will update it whatever the maximum in both of these. And in other case, if we don't have a opening bracket in the character array, what we do, we simply append the index value, not the character. Why? Because we need the latest index discontinuous point. That's why. And at the end, we will simply return answer, and it will surely work. And thank you. I hope you like it.